Hi, this one here is a mosquito, the world deadliest animal. So you know, a shark kills more or less around 5 people every year. Mosquitoes kills around 700,000. This one here is an Anopheles, a female, and is the one that transmits malaria. There are other diseases like tuberculosis and intestinal parasites, and those three diseases are on the top 10 of the deadly diseases in low and middle income areas. And the thing that they have in common is that they can be cured easily if they are diagnosed. But still, there are 4 million people dying every year because of those diseases. And from my point of view, that's unacceptable. It's not just about dying, okay? Because yeah, dying could be horrible, but those people have an extra problem. So we are talking about people who are in a really, really fragile situation. So those people can go, so if you cannot work so and you're living with 2 years a day, not being able to work makes that you cannot eat this day. So you won't be able to go to school. You won't be able to do a lot of things. So brings it from a fragile, from a really bad situation to an even worse situation. And again, so the main idea is that they are curable if they are diagnosed, and that's what we are gonna do. So until now, the approach for those diseases is that, so the way to diagnose them is basically you have a microscopist, which is a person who looks through a microscope, which is an device that is really expensive, costs around 2,000 euros. So you need a trained person and a really expensive device. And you need to bring it to the most isolated areas of the world where those diseases happen, which is a really difficult combination. But there has been people, like this one here, this is AIScope. That's an foldable microscope that was aiming to solve this problem of diagnosis. And that was actually, I showed this picture because that was actually what gave me the idea of how to start developing this project. AIScope is a foldable microscope, as I said, but I realized, yeah, that's amazing. You can ship them everywhere, but you need someone to look through. So let's use AI, which is what I know how to do, to solve this problem. And I started doing that. So first I built a AIScope. This here on your link side, that should be like a blood test, blood sample. And as you can see, that's horrible quality. So I saw that I had to create my own microscope. So first I went to Amazon and I bought a microscope, a cheap Chinese microscope, which was aiming to have 1000x magnification, which is what you need to see malaria. But obviously it was a low quality Chinese microscope and I could only get 200. So you could actually see the cells, that's the same sample, but you cannot see inside. So what I did was, I'm a maker myself, I'm an engineer, so I disassembled that, I changed the sensor, so it mounted a 0.3 megapixel sensor, so I put a 8 megapixel sensor, and I moved it a bit backwards. So the idea is that the more far away you are from the objective, the more the light is gonna open and you're gonna magnify. But as I'm not an optician, that's me working, I realized that, yeah, that's a good idea on the paper, but what gives you the resolution is the objective. And this microscope has a really bad objective. So I had to go to creating my own microscope from scratch. The idea of AIScope is that it needs to be able to be manufactured everywhere in the world without the need of complex machines. So that's why the first version I went to use wood, because you can find it everywhere. It has wood, bolts, and objective and an eyepiece that you can buy in Amazon. The cool thing is that it costs under 50 euros, the materials, if you buy them in Amazon. So that was the first version. It kept improving, so it gets more complex. Here the idea is that you put here, like there's no laser, whatever. Here in the middle, you can see the objective, and in the front, you put your sample there, and it automatically moves everything because it has an Arduino that moves and refocuses everything. And yeah, and as you can see, that's the difference of qualities. On the right side, it's our microscope, That, yeah, it definitely has less quality than a medical microscope, but it costs less than 50 euros in comparison with 2,000 that costs a normal microscope. For the software, the idea was easy. So what came to my mind was, okay, if Facebook can recognize my face, I mean, that's stupid not to use that to recognize parasites. It shouldn't be difficult. So yeah, so I started, what I want to show you is the first version of the software, which was really, I know, we have been developing that to a second version, which is already in GitHub, and we are developing the third one. So this one here was easy. We use, there's a sample of malaria, of blood with malaria. All those dots here are parasites. Here in the middle, you can see them. So and they are a bit dark. So what I thought first, like, okay, let's focus on the dark areas, and let's test my model there. It was so easy as there. You get several different candidates and go for the best one, and boom. At the end, you get the diagnosis. The cool thing that it works better than doctors. And yeah, so we started with this one here, which is really easy. We use TensorFlow, really, really easy. Then we moved to SSD to do it faster. And right now, as we are using, focusing also in other diseases, because we started only with malaria, but now we have tuberculosis and intestinal parasites, we are moving to mask CNN, which was super fast, super easy, and actually it's amazing, the good result that you can get. And yeah, so the cool thing, computer vision can diagnose infectious diseases, which is amazing. That's something that that for you guys might sound obvious, but for a lot of medical people, they don't really realize how much work they are wasting into things that can be done by easy AI, because that's a piece of cake, easily. I didn't invent anything, I just put things together. So that's the actual microscope, the last version. Right now we are developing a next one, which is going to be even faster. So a normal malaria test takes you around 30 minutes, and the next version we aim to do it in less than 1 minute, because you have to test 500 different fields of the slide, and we are developing one microscope that takes one picture of the whole slide together, which is going to be really revolutionary. Yeah, we do believe AI should be used for good. And yeah, there's a lot of people who are going to use it for evil, but we are the good ones and we have to use it for good. We are AIScope, again, we are open source, we are non-profit. We don't have any big corporation behind, we are just doing that ourselves. We are currently working really, really into the project. There should be like 12, 13 people, but somehow involved, there are like 25 scientists all over the world. We have been invited to congresses in New Orleans, in a lot of different places, in the World Health Summit, because they like a lot the project. And it's open source, so if you want to help with the community and with your skills, you're totally welcome. The last thing is that, as you know, for developing a good AI, whatever you want to do, you need a data set. No one is sharing their data set about the diseases, about infection diseases. So what we thought is, okay, let's do something cool. Let's create a global data set of infection diseases that it's going to be open. So what we are currently doing is dealing with labs, universities, and hiring microscopists all over the world to collaborate with this data set. So because at the end, we don't want to get the glory of this project. What we want is to solve the problem. We want to bring microscopy to the most isolated areas of the world. So if you know how to do it better, perfect. You're totally welcome to help us. So that's me. If you have, now I guess we are going to have questions, but if you have further questions, you can contact me, add me on LinkedIn. You can visit this website and please share it, because that would be lovely if you can share AIScope.net.